I don't keep anything in the topic slide because then we get very boring by seeing that a lot many things we have to cover. No, so we'll find this gradually slide by. Let's start with some kind of applications that we are having in present days as a challenging applications. Okay, so these are simply called RMS applications, where the basic purpose is we from some kind of images. That image may be any GIS image, that may be some medical image or something, from where we have to recognize some patterns. That pattern may be for tumor, that pattern may be for any kind of other disease, or dislocation of any bones or something, or broken up bones. So from this image, we have to recognize whether something is there. If there, then what is the exact location of something, and we have to accordingly synthesize that whether it is how frequently it is getting enlarged or something. If this is the case, how frequently, how long should we go for treatment or something, what should be the treatment strategy at all. So these are a very commonly field where high performance computing is used nowadays. Similar, we have lot many other application domain like game physics, movie physics, then in share markets for financial analysis and all these things. Then in other kind of retracing based rendering applications like gaming and all. Okay. So this I'll just go through to give you a brief idea that there are some fields like in computer vision, image processing in virtual world, like 3D and all. Then processing of video or data somewhere that is available. In the field of bioinformatics also, like the human genome projects and everywhere. In case of geology, for earthquake prediction or something like that. And in the industry also for modeling, different kind of maybe cars or some aircraft or something. But for modeling also we require the computers to be used, and this application requires some huge amount of computational efforts. So it's a huge area or application domain where parallel computers or high performance computers are used, starting from your biology to physics to chemistry, even for numerical simulation in medical, for in the field of different engineering and other application domains in the field of computer science, in the field of oceanography. There are lots of application domain where this kind of computers are used. So what we have seen so far that we have a large number of applications that requires huge computational power to be involved to find some kind of solutions, and which are beyond the capability of present desktop computers or laptop computers, whatever you have in our laboratories in general. So this is one observation that we have lot many application domain where our traditional computers are unable to provide you the support that they expect from the computational point of view. Second thing, we find that there are lot many parallelism here and there. Even if we find our environment, we will find lot many places where there are parallelism already exist. So you have to consider these two things in mind whenever we will be going further. Then the second observation is, depending on the application domain, the requirement of different applications are distinct. You cannot say like if we design a computer for this application, that will be a good design for some other applications. Someone requires very high processing and memory system performances. Some other application may require high throughput even. Some other may require huge amount of network bandwidth to be provided. So different application utilizes different aspect of parallelism or high performance computers that we are having. So two things, we have some applications that we need to solve, which were not possible long before, but as the time passes and development happened, now we are in a position that we can solve some of those kind of problems. And different problems have different kind of requirements. So one particular system will not work for each and every application. That thing also you have to keep in mind. So to solve this problem, we need huge computational effort. But our traditional computers cannot provide such kind of huge processing power or capability. So what to do? So that old cliche, necessary is the mother of invention, still remains effective and correct, that when we require something, then based on that we do some kind of development. So as we have lot many such applications, which are not possible to solve using our traditional desktop computers or laptops, whatever we are having. We require some computers that will be having huge computational power. So this broad term, high performance computing, describes a set of hardware and software techniques developed for building computer systems capable of quickly performing large amount of computational tasks. So here, two things you have to, we should follow that. It's a set of hardware and software, both. It's not only a hardware or neither it's only software. And they will provide huge amount of computational power so that we can quickly perform huge amount of tasks that we require to solve for. So we required first computer, why? To solve computer intensive problems faster, to make some impossible problems that were not possible to solve earlier, to make these are feasible nowadays, and solve large problems in same amount of time. It should not take any MRI machine to take the image and give a result to 10 days to bring out the report. By that time, the patient will go off. So we require the results to be in real time. And to improve the answers, the precision of the answers, we require fast computers to reduce the design time of different kind of applications that if you do using pen and pencil, it will take time. Rather, if you can have some kind of software, they will design in a faster way. And obviously, to gain competitive advantage, we require fast computers. But how to increase this computational power? It's not a magic, right? So we'll go through how can we increase the computational power towards solving this problem. So from simple computers, we are going to build high performance computing systems gradually from the very fundamentals, because all of you are not from the computer science background. Assuming that, I'll just go through the pinpoints of the basic structural issues or design issues where we must keep on pointing to improve the performance of the computer systems.